I am Radhakrishna, your mathematics teacher. Today we are going to start the second day of circles, and before starting the second day of circles, let us have a quick look at the points discussed in the last class. Yeah, we discussed the definition of a circle, that locus of a point P which moves at a fixed distance R from a fixed point C is a circle, and R is called radius, C is called center. Next point, equation of the circle with the center h comma k and radius R is x minus h whole square plus y minus k whole square is equal to R square, and the general equation of a circle is x square plus y square plus 2gx plus 2fy plus c is equal to 0, and if g square plus f square minus c is negative, it is called imaginary circle, and g square plus f square minus c is equal to 0, then it is called a point circle, and if g square plus f square minus c is greater than 0, it is a real circle, because radius of the circle R is square root of g square plus f square minus c, radius of the circle, and the center of the circle is c is equal to minus g minus f. That is why if g square plus f square minus c is negative, it is imaginary circle. If it is 0, radius of the circle will be 0, then it is called a point circle. Next point, if the second degree equation ax square plus 2hxy plus by square is plus 2gx plus 2fy plus c is equal to 0 represents a circle, the conditions are a is equal to b and h is equal to 0. Next, standard notation. The expression in the general equation of a circle x square plus y square plus 2gx plus 2fy plus c is denoted by s, and this expression x1 plus y1 plus g into x plus x1 plus f into y plus y1 plus c is denoted by s1, and x1 square plus y1 square plus 2gx1 plus 2fy1 plus c is denoted by s11, and s12 is x1 x2 plus y1 y2 plus g into x1 plus x2 plus f into y1 plus y2 plus c, and s22 is x2 square plus y2 square plus 2gx2 plus 2fy2 plus c. Next, diameter form of a circle. If the ends of the diameter of a circle are ax1 y1 and bx2 y2, the equation of the circle is x minus x1 into x minus x2 plus y minus y1 into y minus y2 is equal to 0. And parametric form of the circle. If you take the center at origin, radius is r, the equation of the circle is x square plus y square is equal to r square, and the coordinates of any point on the circle can be expressed as x is equal to r cos theta and y is equal to r sin theta. They are called parametric equations. And if the center of the circle is h comma k, the parametric equations of the circle would be x is equal to h plus r cos theta, y is equal to k plus r sin theta, where theta is called parameter. Equation of a family of circles. If you take a circle and a line intersecting at A and B, if the equation of the circle is s is equal to 0 and the equation of the line is L is equal to 0, the equation of any circle passing through the intersection points, we can draw so many circles passing through the intersection points, and equation of any such circle will be in the form of s plus lambda L is equal to 0, where lambda is any real number. We can call it as a parameter. Next point, suppose that line touches the circle. Circle is like this and the line is like this. Then any circle touching both the line and the circle at the same point will be in the form of s plus lambda L is equal to 0, where s is the circle, L is the line. So, these are the points discussed in the last class. Now, let us start the session. Power of a point. What is power of a point with respect to a circle? If P is any point on the plane of a circle of radius center C and radius R, then Cp square minus R square is called power of the point P with respect to the circle. Suppose the circle is like this. C is center, R is radius. If there is a point P anywhere, maybe inside or outside, then Cp square minus R square is called power of P with respect to the circle. Now, the power of the point x1, y1 with respect to the circle S is equal to 0 is S11. Let us see how. Suppose the circle is x square plus y square plus 2gx plus 2fy plus c is equal to 0. S is equal to 0. Now, you want the power of a point P x1, y1 with respect to the circle. What is the formula for center of the circle? C minus G comma minus F is center. And what is the radius of the circle? R is equal to square root of G square plus F square minus C. Now, let us calculate Cp square minus R square. Cp square minus R square will be, use distance formula, you will get x1 plus G whole square, x1 minus x2 whole square plus y1 minus y2 whole square, that is x1 plus G whole square plus y1 plus f whole square minus R square. What is R square? Minus of G square plus F square minus C. You simplify, G square cancels, F square cancels, minus of minus C becomes plus C. Now, this expression becomes x1 square plus y1 square plus 2gx1 plus 2fy1 plus C. And just now we discussed that this is denoted by S11. Okay. So, the power of a point is initially defined as Cp square minus R square. Now, the formula for power of a point P with respect to a circle S is equal to 0 is given by S11. How do you calculate S11? Just by substituting point P in the equation, the value of this expression is S11, that is power. Now, what is the importance of the power of a point P? If a point P is outside the circle, then Cp, distance of P from the center, is greater than the radius. If the point P is inside, then the distance of P from the center will be less than the radius, is it not? If the point P is on the circle, then distance of P from the center is equal to radius. So, when P is outside, since Cp is greater than the radius, Cp square minus R square will be positive, means S11 is positive. And if P is inside the circle, then Cp is less than the radius. So, Cp square minus R square will be negative. Therefore, when S11 is less than 0, then point P lies in the interior of the circle or inside the circle. When P is on the circle, then Cp will be equal to the radius. So, Cp square minus R square will be 0. So, if S11 is 0, then the point P lies on the circle. Okay. So, if you want to know whether the point is inside or outside or on the circle, just you substitute the point in the equation, and then the value of the expression, if it is positive, point is outside, if it is negative, point is inside, if it is 0, point is on the circle. Okay. Next, if a secant line drawn through a point P x1 y1 meets the circle S is equal to 0 at capital A and capital B, then what is this? Then the power of PA into PB will be equal to S11. First, what is a secant line? If a circle is like this, take any point P on the plane of the circle. Through P, if you draw a random straight line intersecting the circle, it is called a secant line. If the secant line intersects the circle at capital A and capital B, then the product of the sine distances PA and PB, PA into PB is a constant, means in whatever direction you draw the line, suppose this is C, this is D, PC into PD will be same as PA into PB, it is equal to this into this, the value is S11, power of the point. Okay. And how to prove this? Let us take the circle S is equal to 0. Let the circle be like this, and let the point P be x1 comma y1. Now, let us draw a straight line with slope tan theta. Then the equation of the line can be parametrically expressed as the parametric equations of the line be x is equal to x1 plus r cos theta comma y is equal to y1 plus r sin theta. Where theta is any real number. Okay. So, there theta is the parameter. In the parametric equations of a straight line, theta will be the parameter. Okay. Now, solving the equation of the line in parametric form and the equation of the circle. That means, substitute x is equal to x1 plus r cos theta, y is equal to y1 plus r sin theta in the equation of the circle. What will you get? x1 plus r cos theta whole square plus y1 plus r sin theta whole square plus 2gx, 2 into g into x is x1 plus r cos theta plus 2fy, 2f into y is y1 plus r sin theta plus c is equal to 0. By solving the equation of the line and equation of the circle, you will get the points of intersection. Okay. Here, this is a quadratic equation in R. Okay. So, the roots of R in the quadratic equation will be the sine distances of A and B from P. Okay. Why I am saying sine distances? sign distances will have either plus sign or minus sign. Here PA and PB are in the same direction. So, here PA and PB will have same sign. Suppose the point P is inside the circle, then PA into PB will be negative because PA and PB are in opposite directions. Okay, that is why they are called power or sign distances. Now, it is a quadratic equation in R. The roots of R will be PA and PB. You want PA into PB. PA into PB will be product of the roots of this quadratic equation. In a quadratic equation, how do you find the product of the roots? Constant term by coefficient of x square. So, here the product of the roots will be the constant term, means term independent of R divided by coefficient of R square. What is the term independent of R? You can tell without expanding, without simplifying the equation, we can tell the term independent of R. If you want term independent of R, just to take R is equal to 0, then what will you get? X1 square plus Y1 square plus 2gx1 plus 2fy1 plus c. Putting R is equal to 0, you will get the term independent of R. This is constant term, term independent of R, divided by coefficient of R square. What is the coefficient of R square? Without expansion. Here coefficient of R square is cos square theta, here sin square theta. So, coefficient of R square is totally cos square theta plus sin square theta, that is 1. So, this divided by 1, and this is denoted by S11 in our standard notation. So, PA into PB is equal to S11. Okay. When P is outside, then power is positive because PA and PB are in same direction. When P is inside, then PA and PB are in opposite direction, so they will have opposite signs. So, their product is negative. We know that when P is inside, S11 is negative. Okay. So, finally, we have 3 expressions for power of a point. One is Cp square minus R square, another is S11 and another is PA into PB. So, power has 3 different formulae. Okay. Now, the length of the tangent from an external point P x1 y1, length of the tangent from an external point P x1 comma y1 to the circle S is equal to 0 is root S11. How? In your lower classes, you must have studied one property. If P is an external point, if PAB is a secant line, then all of you know that PA into PB is equal to PT square. What is PT? Length of the tangent. Okay. If the tangent from P touches the circle at T, then PA into PB is equal to PT square. And just now we proved that PA into PB is S11. Therefore, PT will be equal to root S11. So, this is a formula you should need to remember. The length of the tangent from an external point x1 comma y1 to the circle S is equal to 0 is root over S11. Okay. Next point, the length of the chord of a circle, the length of the chord of a circle S is equal to 0 having midpoint at P x1 comma y1 is root over mod S11. Take a circle like this, draw a chord, let the midpoint of the chord be P x1 y1. Now, I want length of the chord. Let the extremities of the chord be A and B. Now, just now we proved that PA into PB is S11, but here over here S11 is negative because P is inside. Okay. Now, if we take mod, then it becomes positive, but when P is midpoint of AB, mod PA is equal to mod PB. So, it is equal to mod PA square is mod S11. So, mod PA is equal to root over mod S11, but this is half of the length. So, what is the length AB? Length AB, it should be 2 root S11, 2 root mod S11. So, length AB is going to be 2 root mod S11. So, this is the formula for length of the chord of a circle having midpoint at Px1, y1. Okay. Next point, X and Y intercepts of a circle. Suppose a circle cuts the x axis at A and B, y axis at C and D. Then AB is called X-intercept, CD is called Y-intercept. How to calculate the length of the X-intercept and length of the Y-intercept of a general circle? Let the circle be S is equal to x square plus y square plus 2gx plus 2fy plus c is equal to 0. For getting the points A and B, what will you do? You will solve the equation of the circle and equation of the x-axis. What is the equation of x-axis? Y is equal to 0. Solving these two means putting y is equal to 0 in the equation of the circle, we get a quadratic equation, x square plus 2gx plus c is equal to 0. The roots of this quadratic equation are the abscissa of A and B. Suppose A is x1 comma 0, B is x2 comma 0, then x1 and x2 are the roots of this equation. Then what do you want? Length of the chord. AB is equal to mod x1 minus x2. X1 and x2 are the roots of this equation. So, it is magnitude of the difference of the roots. What is the formula for magnitude of the difference of the roots? Magnitude of the difference of the roots of a quadratic equation is given by the formula root delta by mod A. It is equal to root delta means square root of b square minus 4ac, 4g square minus 4c by 1, that is 2 root g square minus c. So, formula for length of the x-intercept is 2 root g square minus c. Similarly, length of the y-intercept will be 2 root f square minus c. This is 2 root g square minus c, this is 2 root f square minus c. You need to remember these formulae, x-intercept and y-intercept of a circle. Now, if g square is less than c, what happens? X-intercept is imaginary, then how will be the circle? There will be no real points of intersection. So, if the axes are like this and circle is not intersecting the x-axis, it lies on one side of the x-axis, either above the x-axis or below the x-axis. In this case, g square will be less than c. Similarly, if f square is less than c, then y-intercept is imaginary, then the circle does not touch or intersect the y-axis. Okay. So, if g square is less than c, the circle does not touch or intersect the x axis, and if f square is less than c, the circle does not intersect or touch the y axis. If g square is equal to c, then x-intercept is 0, then how will be the circle? When the two points A and B coincide, the circle touches the x axis like this. So, in this case g square will be equal to c. Similarly, when the circle touches the y axis like this, then f square will be equal to c. If f square is equal to c, the circle touches the y axis. If g square is equal to f square is equal to c, then the circle touches both the axes. So, the circle is going to be like this. The circle touches both the axes means it will be like this. If g square is equal to f square is equal to c. Okay. These are the formulae for a circle to touch the x axis or y axis. Okay. Moving to, that is point number 1, length of the x-intercept. Length of the intercept made by the circle on x axis 2 root g square minus c, and length of the y-intercept is 2 root f square minus c. If g square is equal to c, the circle touches the x axis. If f square is equal to c, the circle touches the y axis. If g square is equal to f square is equal to c, the circle touches both the axes. Next point. Yeah, we have discussed these points. Now, if a circle touches the x axis, then the y coordinate of its center will be equal to radius of the circle. Suppose a circle touches the x axis like this, then the y coordinate of the center will be equal to radius of the circle. Similarly, if a circle touches the y axis, then if a circle touches the y axis, then the y x coordinate of the center will be equal to radius of the circle. Next, this is very important. Suppose a circle of radius r touches both the axes, then the equation of the circle is x square plus y square plus or minus 2rx plus or minus 2ry plus r square is equal to 0. Draw a circle touching both the axes. Okay. If the radius of the circle is r, then this is r, this is r. So, what will be the coordinates of the center? Center will be r comma r. Center is r comma r, radius is r. So, what will be the equation of the circle? X minus r whole square plus y minus r whole square is equal to r square. If you simplify, you will get x square plus y square minus 2rx minus 2ry plus r square is equal to 0. Similarly, if the circle lies in the second quadrant touching both the axes, then the center of the circle will be minus r comma r. Then this will be x plus r whole square, this will be y minus r whole square is equal to r square. Similarly, the circle may be in third quadrant or fourth quadrant. So, the equation of the circle is x plus r minus r whole square plus y plus r minus r whole square is equal to r square. Then you will get x square plus y square plus or minus 2rx plus or minus 2ry plus r square is equal to 0. So, here over here if the circle lies in the first quadrant, we have to take minus and minus. If the circle lies in the second quadrant, we have to take plus and minus. For third quadrant, plus plus. For fourth quadrant, minus plus. Okay. Now, let us start the problems. Problem 1, find the locus of the perpendicular from 2 comma minus 1 to the family of lines a plus 2b into x plus 2a minus 3b into y minus of 3a minus b is equal to 0, where a and b are real numbers. First, you tell what kind of family is this. You can write this equation as a into x plus 2y a into x plus 2y minus 3 plus b into 2x minus 3y plus 1 is equal to 0. This is the equation of the family. If there are two fixed lines L1 and L2, then the equation if L1 and L2 are two given lines, then the equation lambda 1 into L1 plus lambda 2 into L2 is equal to 0 represents a family of lines passing through the point of intersection of L1 and L2. If the lines are like this, any line passing through the point of intersection will be in the form of lambda 1 L1 plus lambda 2 L2 is equal to 0. So, this is a family of concurrent lines. Okay. And what is the point of concurrence? It will be the point of intersection of this line and this line. Let us find the point of intersection. Solving the equations x plus 2y minus 3 is equal to 0 and 2x minus 3y plus 1 is equal to 0, we will get the point 1 comma 1. Solving the two lines, we get the point of intersection 1 comma 1. So, this is a family of lines passing through a fixed point. Now, let the point of intersection be denoted by A, it is 1 comma 1. Now, what do you want? Find the locus of the foot of the perpendicular from this point 2 comma minus 1 to the family of lines. So, let us take that point as B. B is 2 comma minus 1. Now, if you draw perpendiculars from B to these lines like this, let P be the foot of the perpendicular, then this angle is pi by 2 for any position of P. Wherever you draw the perpendicular, if P is foot of the perpendicular, angle APB will be pi by 2. Then what is the locus of P? P moves on circle with AB as diameter. The locus of P will be circle with AB as diameter. So, indirectly we are asked to find the equation of the circle with AB as diameter. So, how to find it? We have discussed diameter form. x minus x1 into x minus x2 plus y minus y1 into y minus y2 is equal to 0. So, what will be the equation of the circle? Equation of the circle is x minus 2 into x minus 1 plus y plus 1 into y minus 1 is equal to 0. If you expand and simplify, you will get x square plus y square, here minus 3x, no y term, and constant term will be 2, here minus 1, so plus 1. So, this is our answer. Next question. If the lines lambda x minus y plus 1 is equal to 0 and x minus 2y plus 3 is equal to 0 intersect the coordinate axis at 4 concyclic points, then find the value of lambda. So, if the coordinate axes are like this, these two lines, what is the first line? X-intercept is minus 1 by lambda, putting y is equal to 0, we get x is equal to minus 1 by lambda, and y-intercept is 1. Y-intercept is 1 means it passes through this point. So, let us take that line like this. And similarly, second line, x-intercept is how much? Minus 3, putting y is equal to 0. X-intercept is minus 3, y-intercept is putting x is equal to 0, 3 by 2. So, let us take the second line like this. So, these points of intersection are concyclic. If this is origin, say this is A, B, C, D, then these 4 points lie on a circle. Then what is the value of lambda? Usually many students are solving this question like this. What is y-intercept of the first line? 1. So, this point is 0 comma 1. Y-intercept of the second line, it is 3 by 2. So, this point is 0 comma 3 by 2. And x-intercept of the second line is minus 3. So, this is minus 3 comma 0. And x-intercept of the first line is minus 1 by lambda. So, this is minus 1 by lambda comma 0. Many students are solving like this. First they will find the equation of the circle passing through B, C, D, because points are completely known. Then in the equation of the circle, by substituting minus 1 by lambda, you will get the value of lambda, but that is very long. You can use the property which we proved just now, that here OAB is a secant line for the circle, OCD is a secant line, and we know that OA into OB is equal to OA into OB is equal to OC into OD. So, what is OA into OD? OA into OB minus 1 by lambda into minus 3, 3 by lambda is equal to OC is 1 and OD is 3 by 2. So, 1 into 3 by 2 is 3 by 2. So, simply we get lambda is equal to 2. Okay. Moving to next question. Find the equation of the circle through 6 comma 5 and 4 comma 1 and having the center on the line 4x plus y minus 16 is equal to 0. Let us denote these points by let us denote these points by A and B. circle passes through A and B. Okay, draw a circle passing through A and B, and it has center on the line 4x plus y minus 16 is equal to 0. So, through the center draw some line. Let the center be C. For finding the equation of the circle, you need center and radius. So, first let us calculate the center. We know the property that perpendicular from the center on any chord bisects the chord, or perpendicular bisector of any chord passes through the center. So, let us find the perpendicular bisector of AB. How to find perpendicular bisector of AB? Find the midpoint of AB, x1 plus x2 by 2, y1 plus y2 by 2, 6 plus 4 by 2, it is 5, comma 5 plus 1 by 2, it is 3. Midpoint is 5 comma 3, and what is the slope of AB? Slope of AB is y2 minus y1 by x2 minus x1, 5 minus 1, 4 by 6 minus 4, 2. So, slope of AB is 2. Then what is the slope of the perpendicular bisector? Minus 1 by 2. If two lines are perpendicular to each other, product of the slopes is minus 1. So, if one slope is m, the perpendicular line will have slope minus 1 by m. So, taking the perpendicular slope minus 1 by 2 and the point 5 comma 3, equation of the perpendicular bisector of AB is y minus 3 is equal to minus 1 by 2 into x minus 5. Simplifying, cross multiplying by 2, 2y minus 6 is equal to minus x plus 5, or x plus 2y minus 11 is equal to 0. And this line passes through the center of the circle, and center also lies on this line. So, point of intersection of this line and this line will be the center. So, let us solve this. Solving with 4x plus y minus 16 is equal to 0. How to solve? Multiply the second equation by 2 and subtract the first equation. Multiplying the second equation by 2, 8x plus 2y minus 32 is equal to 0. Subtracting the first equation, we get 7x, this minus this, 21, minus 21 is equal to 0. We get x is equal to 3. Putting x is equal to 3 in any one of the equation, let us substitute here. 3 plus 2y minus 11 is 0. So, 2y minus 8 is 0, y will be 4. So, center of the circle will have coordinates 3 comma 4. Then, how do you get the radius? Radius of the circle is distance of center from any point. We know 2 points on the circle. So, radius r will be, first we write the center, center C is equal to 3 comma 4. Now, radius will be r is equal to, calculate the distance of C from any one of the 2 points. I will calculate from this point. Root over 4 minus 3 whole square 1 plus 1 minus 4 whole square 9. So, radius is root 10. Then what is the equation of the circle? Equation of the circle is x minus h whole square plus y minus k whole square is equal to r square formula. We have x minus 3 whole square plus y minus 4 whole square is equal to 10. R square is 10. Okay. If you want, you can expand. Moving to next question. Find the equation of the circumcircle of the triangle formed by the lines x plus y is equal to 6, 2x plus y is equal to 4 and x plus 2y is equal to 5 without finding the vertices. This is very, very important, because already in the previous class we discussed how to find the equation of the circle when 3 points are given. I explained 3 methods. So, by finding the vertices means by solving the equations and getting the 3 vertices, you can find the equation of the circle, but that is very long and that is not allowed also in the question. Now, if you want to find the equation of the circle, take the diagram. Let ABC be a triangle and circumcircle is drawn. Let the equations of the sides be L1, L2, L3. Now, I will form a second degree equation using L1, L2, L3. Okay. If you want second degree equation, you know that each line will have a first degree equation. Every equation of any straight line will be a first degree equation. So, if you want second degree equation, you have to multiply 2 lines at a time. So, I will multiply L1, L2 and again L2, L3 and again L3, L1. Each one is a second degree equation, but I want an equation consisting of all the 3 equations. So, I will take the equation L1, L2 plus some lambda into some constant lambda into L2, L3 plus some other constant mu into L3, L1 is equal to 0. Now, we can say that this is a second degree equation in x and y. So, this represents some curve. It may be a circle or ellipse or hyperbola or parabola. But we can say that this line, this curve, whatever it is, definitely passes through all 3 points. How can you say? First, A is the point of intersection of L2 and L3 now. So, A satisfies L1, L2 and L3. So, if we substitute A, this L2 will be 0. Oh, so, first term is 0. Here both L1 and L2 and L3 are 0. Here L3 is 0. So, when you substitute A, irrespective of values of lambda and mu, the equation is satisfied. Similarly, if you substitute B, because of L1 first term is 0, because of L3 second term is 0. B satisfies L1 and L3 no, and because of L1 and L3 third term is 0. So, the equation is satisfied for any value of lambda and mu. Similarly, C also satisfies the equation, means it is a second degree curve definitely passes through A, B, C. But I want a circle passing through A, B, C. We have condition for a second degree equation to represent a circle. What are the conditions? Coefficient of x square is equal to coefficient of y square and coefficient of xy is 0. So, I will write this equation first. L1 into L2 x plus y minus 6 into 2x plus y minus 4 plus lambda into L2 L3 2x plus y minus 4 into x plus 2y minus 5 plus mu into L3 L1 x plus 2y minus 5 into L1 x plus y minus 6 is equal to 0. This is some curve passing through A, B, C for any values of lambda and mu. Now, I want the values of lambda and mu for which this equation is a circle. So, what are the conditions? Coefficient of x square is equal to coefficient of y square. You can calculate the coefficient of x square and coefficient of y square without expanding the equation. What is the coefficient of x square here? This into this, 2x into 2x, so 2. Here 2x into x, so 2 into lambda, 2 lambda. In the third term, x into x, x square, so mu x square, coefficient is mu. So, plus mu is equal to coefficient of y square. What is the coefficient of y square in the first term? Y into y, y square, coefficient is 1, plus in the second term, coefficient of y square, y into 2y into lambda, that is 2 lambda y square, coefficient is 2 lambda. In the third term, 2y into mu, so 2 mu will be the coefficient, plus 2 mu. Then we get 2 lambda cancels, we will get mu is equal to 1, mu is equal to 1. And what is the other condition? Coefficient of xy is equal to 0. Coefficient of xy should be 0. You can also calculate coefficient of xy without expanding. X into y, xy plus y into 2x, 2xy. So, here coefficient of xy is 3, 2xy plus xy, 3xy. So, 3 in the second term, 2x into 2y, 4xy, y into x, xy, 4xy plus xy, 5xy into lambda. So, coefficient is 5 lambda. Next, in the third term, x into y, xy, 2y into x, 2xy. So, 3xy you are getting into mu. So, 3 mu should be 0. Substituting mu is equal to 1, 3 plus 5 lambda plus 3 is equal to 0. So, lambda will be minus 6 by 5. So, the equation of the circle is, by substituting lambda and mu, here lambda minus 6 by 5, here I will substitute 1. So, this is the equation of the circle. If you want to simplify, you can multiply and simplify. Okay. So, this is the method of finding the circumcircle of a triangle when the equations of the sides are given. Do not find vertices. Next, this time 4 lines are given, 5x plus 3y minus 9 is equal to 0, x minus 3y is equal to 0, 2x minus y is equal to 0, x plus 4y minus 2 is equal to 0. They form a cyclic quadrilateral in that order. Then find the equation of the circumcircle. Consider a circle and draw a quadrilateral. It is called a cyclic quadrilateral. I want the equation of the circumcircle. Now, Is it possible to find the equation of circumcircle without finding the vertices? When it is possible for triangle, definitely it should be possible for quadrilateral. Now, let us take the vertices as A, B, C, D. Let this equation be L1, this is L2, L3, L4. This is L1, this is L2, L3 and this is L4. Now, we have to form a second degree equation containing all 4 equations. Does it mean that we should take L1, L2 plus something constant into L2, L3 plus some constant into L3, L4 plus some constant into L4, L1, something like that? No. That curve should pass through all 4 points, no? So, what we should do is, we should multiply opposite vertices this time. L1 opposite lines, take L1 into L3 plus lambda into L2 into L4. Now, it contains all 4 equations now. Now, let us check whether it passes through all 4 points or not. It is a second degree equation, no doubt. Product of the equations of 2 lines is a second degree equation always. Now, does it pass through all 4 vertices? Let us check. If we substitute A is intersection point of L1 and L4. So, if we substitute A, because of L1 first term is 0, because of L4 second term is 0. So, 0 plus lambda into 0 is 0. So, it passes through A. Similarly, check point B. B is the intersection point of L1 and L2. So, because of L1 this will be 0, because of L2 this will be 0. So, it passes through B. Similarly, checking C and D, it will be the equation will be satisfied. So, this curve passes through A, B, C, D for all values of lambda. Okay. So, this is some curve. It may not be a circle. For some value of lambda, it may be a circle, but for some other value of lambda, it may be a parabola or ellipse or hyperbola. Now, what is the value of lambda if it is a circle? L1 into L3, let us write this equation first. L1 into L3 means 5x plus 3y minus 9 into L3 2x minus y plus lambda into L2 L4. What is L2? X minus 3y into L4 x plus 4y minus 2. Is equal to 0. Now, if it is a circle, what is the condition? Coefficient of x square is equal to coefficient of y square, A is equal to B. In the general form of second degree equation, if it is a circle, A is equal to B and H is equal to 0. What is A coefficient of x square? Tell coefficient of x square, 5x into 2x, it is 10x square, so 10. In the second term, x into x square into lambda, so lambda. It is equal to coefficient of y square, B is coefficient of y square. What is it? 3y into minus y, minus 3y square, so minus 3. In the second term, minus 3y into 4y, so minus 12y square into lambda, so minus 12 lambda. So, these two should be equal. So, taking minus 12 lambda this side, you will get 13 lambda is equal to minus 13. So, lambda is minus 1. Now, how do you get the equation of the circle? substituting lambda is equal to minus 1 here and opening, multiplying the product and simplifying, we get the equation of the circumcircle without finding the vertices. Now, I have got a question. Here I used only one condition and got the value of lambda. There is another condition also. If you apply h is equal to 0, let us see what we get. What is the coefficient of xy? 5x into minus y minus 5 minus 5xy. Next 3y into 2x, 6xy, so plus 6. Here lambda into x into 4y, 4xy, so lambda into 4. Next minus 3y into x, minus 3 into lambda, so minus 3 should be 0. Now what are you getting? Again lambda is equal to minus 1 you should get. What if you get a different value of lambda? Simply it is not a cyclic quadrilateral. If you take some random lines as L1, L2, L3, L4, they may not form a cyclic quadrilateral. In that case, we get different values. So in this way we can check whether they form a cyclic quadrilateral or not. And also you must take the lines form cyclic quadrilateral in this order, means L1, then L2, then L3, then L4. If you change the order, you may not get cyclic quadrilateral. Okay. So this is the method of finding the equation of the circumcircle of a triangle and equation of the circumcircle of a quadrilateral, cyclic quadrilateral. Now next question. Find the equation of the circle touching the line x plus y minus 3 is equal to 0 at 1, 2 and passing through the origin. Let this be the line and 1, 2 is on this line. This line is x plus y minus 3 is equal to 0 and 1, 2 is on this line. Now draw a circle touching this line at 1, 2 and passing through the origin. I want this circle. Okay. I will explain two methods. First, method 1, if you draw a line through 1, 2 perpendicular to the given line like this, it passes through the center of the circle. This must pass through center of the circle. Okay. Let the center be C. Then if the radius of the circle is R, what is the slope of this line? Minus 1. So slope of this line will be 1. So taking slope 1, and passing through 1, 2, what is the equation of the line? It is y minus 2 is equal to slope 1 into x minus 1 or x minus y plus 1 is equal to 0. Center of the circle lies on this line x minus y plus 1 is equal to 0. Then how to get the center exactly? If you take center as h comma k, it lies on this line. So, h minus k plus 1 is equal to 0, and center will be equidistant from 1 comma 2 and 0 comma 0. So, equating the distances, h minus 1 whole square plus k minus 2 whole square is equal to square of the distance from the origin, h minus 0 whole square h square plus k square. If you expand the squares, h square and k square will cancel. You will get minus 2h here, minus 4k here, and constant will be 5 is equal to 0. Now, solving this equation and this equation, we get the coordinates of center. Then how do you get the radius? Find the distance of C from origin, you will get the radius. So, this is the usual method that anyone will solve, but I am going to solve this in a different way, and it's very simple way. In method 2, I want to use the property that we have discussed in the previous class. Suppose there is a circle S is equal to 0 touching a line L is equal to 0 at A. Then the equation of any circle touching both the line and the circle at A, there will be many circles like this. Equations of all these circles will be in the form of S plus lambda L is equal to 0. This point we have discussed. Here, where is the circle? Line is given, where is the circle? I want to take this point 1 comma 2 as a point circle. So, I am assuming that this line touches the point circle. Okay. Then my equation S is equal to 0 would be equation of the point circle of 1 comma 2. What is the equation of the point circle? Now, method 2, what is the equation of the point circle? For point circle, center is 1 comma 2, radius is 0. So, my S is x minus 1 whole square plus y minus 2 whole square is equal to 0. This is my circle, S is equal to 0. And what is L? This line is L. Now, we can take this circle in the form of S plus lambda L is equal to 0. So, I will take the required circle as S plus lambda into L, x plus y minus 3 is equal to 0. Now, this circle passes through the origin. So, substituting the origin, 0 minus 1 whole square 1 plus 0 minus 2 whole square 4 plus lambda into 0 plus 0 minus 3 is equal to 0. So, we get lambda is equal to 5 by 3. So, substituting lambda is equal to 5 by 3, you will get the equation of the circle. So, this method is very simple and easy. So, you have to make use of all the properties discussed so far. Now, next question. if the curves a1 x square plus 2h1 xy plus b1 y square is equal to 1, a2 x square plus 2h2 xy plus b2 y square is equal to 1, intersect at 4 concyclic points, find the condition. Suppose this is one curve, it may be any curve, we do not know, but they intersect at 4 points which are concyclic. A circle passes through these 4 points, right. Then what is the condition? Let us take a second degree equation which is a combination of this equation and this equation. Let the 4 points of intersection be A, B, C and D, right. How to take the second degree equation which is a combination of both the equations? If the first equation is say S, second equation is S dash, first equation is S is equal to 0, second equation is S dash is equal to 0. Now we can take a second degree equation containing both S and S dash as S plus lambda S dash is equal to 0. S plus lambda S dash is equal to 0. S and S dash are second degree equations. So for any value of lambda, this is a second degree equation. Okay. Now it is some curve passing through these 4 points of intersection. How can you say? If you substitute A, both the equations will be individually satisfied. So if you substitute A, 0 plus lambda into 0 is 0. So A lies on this curve. Similarly, B lies, C lies, D lies. So this is some curve passing through the 4 points of intersection. Now if the 4 points are concyclic, then there exists a circle passing through these 4 points. So we have to find the condition such that this equation represents a circle. So let us write this: a1 x square plus 2h1 xy plus b1 y square minus 1, yes, plus lambda into a2 x square plus 2h2 xy plus b2 y square minus 1 is equal to 0. S plus lambda S dash is equal to 0. Now if it is a circle, that means if the 4 points are concyclic, then only circle can pass through 4 points. If it is a circle, what are the conditions? If a second degree equation represents a circle, what are the conditions? A is equal to B, means coefficient of x square is equal to coefficient of y square, and coefficient of xy is 0. So I am going to apply both the conditions. If it is a circle, A is equal to B, H is equal to 0. A and B, A, B, H are coefficients of a general second degree equation, ax square plus 2hxy plus by square, etc., etc. What is A is equal to B? X coefficient of x square is equal to coefficient of y square. What is the coefficient of x square here? A1. There plus lambda A2. It should be equal to coefficient of y square B1 plus here plus B2 lambda. This is the condition if it is a circle, but only one condition is not enough. Both the conditions must be satisfied simultaneously. So what is H is equal to 0? Coefficient of xy is 0. What is the coefficient of xy in the first term? 2h1. In the second term, 2h2 lambda. It should be 0. Now, if both are true simultaneously, this lambda and that lambda must be same. What is this lambda? Here lambda into A2 minus B2 is equal to minus of A1 minus B1. So, lambda is equal to minus of A1 minus B1 by A2 minus B2. And here what is lambda? Lambda is minus H1 by H2. Now, we can get the condition by equating these two lambdas. Therefore, required condition is if you equate, you can cancel minus signs, A1 minus B1 upon A2 minus B2 is equal to H1 by H2, or you can write the same condition as A1 minus B1 upon H1 is equal to A2 minus B2 upon H2. Okay. Now, proceeding to next question. If the points M1 1 by M1, M2 comma 1 by M2, M3 comma 1 by M3, M4 comma 1 by M4 are concyclic, find the value of the product M1, M2, M3, M4. In the previous class, we have solved one question. When four points are given, if they are concyclic, find some constant. You remember how we have solved? We found the equation of the circle passing through 3 points and substituted the fourth point in one method. In another method, we have used the property of cyclic quadrilateral, sum of the opposite angles is 180 degrees. But here points are unknown, they are in terms of m. Here that method won't work. But you can notice that all points are similar to each other. Every point is in a particular form. What is that form? A number comma its reciprocal. So, we can say that every point is in the general form t comma 1 by t, where t is either m1 or m2 or m3 or m4. Now, what I will do is if the points are concyclic, there exists a circle passing through the 4 points. I will assume that equation of that circle is S is equal to 0. Let the equation of the circle be S is equal to 0. What is S is equal to 0? X square plus y square plus 2gx plus 2fy plus c is equal to 0. Okay. Now, there are 4 points which are in the form of t comma 1 by t on this circle. So, I will substitute t comma 1 by t in this equation, substituting t comma 1 by t. What will you get? T square plus 1 by t square plus 2gt plus 2f by t plus c is equal to 0. You can multiply both sides by t square, then you will get t power 4 plus 1 plus 2gt cube plus 2ft plus ct square is equal to 0. This is a biquadratic equation, fourth degree polynomial equation. A fourth degree polynomial equation will have 4 roots. Here what are the 4 roots of this equation? Clearly m1, m2, m3, m4. Okay. So, the roots are m1, m2, m3, m4. Now, what do you want? Product of the 4 roots. You want the product m1, m2, m3, m4. So, product of the roots of a fourth degree equation is constant term by coefficient of t power 4. What is the constant term in this equation? 1 divided by coefficient of t power 4, that is also 1, 1 by 1 is 1. So, our answer is 1, the value of the product is 1. Okay. Yeah, we are going to close this session for today, and all of you go through the notes. Please, if it is not possible to copy the points in the live lecture, you can later again watch the video and note all the theory points at one place. It will be very, very useful just before the final exam. Okay. So, please maintain the theory notes with all theory points at one place. That will be very, very useful before the final examination. Okay. So, we will meet in the next class with more interesting problems. Until then, have a good day.